Okay, today's lecture is not in the book, but it helps us. This is one of those things that's a skill that would be good to use because I don't know how many of you out there don't like fractions and decimals. This is a way for us to get rid of the fraction, get rid of the decimal, and be able to move forward and solve the equation in a more easier done fashion. Okay, so what we're going to do is, first of all, we have to sit and look at our vocabulary of what a least common denominator is. Okay, and you'll see me use these letters, LCD. Okay, that's what least common denominator means, so we don't have to write it over and over and over, and you'll see that on your vocabulary section on your Power Notes. And what a least common denominator is if I had a couple of fractions, like 1/3 and 1/2, and I was trying to add them together. Well, the problem is I can't add them together because they have different denominators. So what we do to find the least common denominator, we try to find numbers that both 3 and 2 can go into. And we know that 3 and 2 can both go into 6. So 6 becomes our least common denominator. We might have other occasions as well where you might have something like this, 1/8, and let's say 1/24. And again, when you're looking here, when you're having the numbers 8 and 24, you know that the least common denominator is 24, because 8 can go into 24. So sometimes you don't have to change both of them. You can just change one of them to get them to be common. Remember, here's that word common. Okay, they both have to be able to go into the same number. 24 can go into 24. Okay, so when we have our question, is there an easier way to work equations that have fractions and decimals? How? I'm hoping to show you in the next 2 examples that we're going to do. And this will be handy for our next thing that's going to be coming up behind it, which is called mixture problems. So let's take a look at our rules for fractions, and you have them written down there. So it's find the least common denominator, and I wrote LCD because you know that that's what that means. And we're going to multiply all the terms by that number. In other words, every single part of the equation is going to get multiplied by that number. Everything. Okay? Even if it doesn't even have a fraction, it's going to get that number. That's the way that works. So we're going to do one example only. Let's see if we can get this. So I'd like everybody to write this down. 1/3 P plus 1/6 equals 3/2. Okay? Now, we're going to look at the denominators. They're 3, 6, and 2. So let's think about this. What number can 3, 6, and 2 all go into? I know a lot of people are thinking 12 and 18, but there's a smaller number. Isn't 6? Because remember, it's the least common denominator. 3 can go into 6, 6 can go into 6, and 2 can go into 6. Okay, so we did step 1, find the least common denominator. Now we have to do the second part, which is multiply all the terms by that number. You notice how I'm using red. When we do these problems, using a red pencil really helps. It can help you see what's going on and not get confused. So if you want me to wait a few seconds, I will, so that you can get your red pencils out, and that will help you to hopefully keep this level and see what's going on and see what's happening where. Okay, so we have to multiply every term. So I have to multiply this 1/3 times 6. I have to multiply this 1/6 times 6 and this 3/2 times 6. Everybody with me so far? Oops, sorry about that. I want to erase this. Okay, so we're multiplying everything times 6. Now here's where it gets interesting. Because it's a fraction, we're going to put it over 1. Put it over 1. Put it over 1 so that they're fractions. So now we're going to look at things individually. Okay, so we're just going to look at this first part, 6/1 times 1/3 times P, right? So we look at the numerator and the denominator. 3 can go into 6. How many times can 3 go into 6? Twice. So we're going to cross out the 6 and put a 2, and we have a 1 down here. So let's just simplify this first thing before we see what else is going on. So now in the numerator we have 2 times 1 times P, which is 2P. And on the bottom, in the denominator, we have 1 times 1, which is 1. We don't need to put it over 1, because that's good enough. It's simplified. Okay? Let's go on to the next one. Let's bring the plus sign down so we don't lose that. The 6's are going to cancel, aren't they? Because 6 can go into 6 one time. So in the numerator, I have 1 times 1, which is 1. The denominator is 1 times 1, which is over 1. We don't need that. Because remember, this whole process is to get rid of the denominators. So we're not going to have any denominators if we do it right. 2 goes into 6 3 times, and 3 times 3 is 9. Now, isn't that equation in blue that we just did now better than this original one in black? Look at that. Would you want to work in fractions? No. So what we do instead is we get rid of it by least common denominator. This is so much easier. Okay, so let's finish it like a normal two-step equation. Let's subtract 1 from both sides. Okay, and then we're going to, that goes away, and so we get 2p equals 9 minus 1, which is 8. Then we're going to divide both sides by 2 because we want to get the p alone. And we get p equals 4. And we still have to check it. We're never going to get out of all the work. But if we can get out of some of the work, why not, right? So let's put a 4 in there. So we got 1/3 times 4 plus 1/6 equals 3 over 2. Okay, remember this 4 has got to go over 1. So let's fix this. 1 times 4 is 4. 3 times 1 is 3. And right now, it's not looking very pretty, is it? So let's get common denominators over here. In order to do that, if I multiply this 4/3 by 2 over 2, that's going to get me 6 in the denominator, right? So 2 times 3 is 6. 4 times 2 is 8. So now that they have the same denominator, I can put them together. And 8 plus 1 is 9. So 9 divided by 6. And I know if I reduce 9 over 6, I get 3/2. So that's good. So we know that p equals 4 is our answer. And we're good to go. All right. And so that's how we do it by fractions. Again, we're going to find that least common denominator. We're going to multiply every single term by that number, right? And it doesn't matter if it's a fraction or not. It's all going to get it. And then what's going to happen is if we do it right, we're just going to get a normal two-step equation. We're going to follow our rules for that, get an answer, and check our answers. Okay? All right, so now let's take a look at what happens with decimals. And you have the rules right there. It says, find the least power of 10 that is common in all the terms. And then we're going to multiply all the terms by that number. So that rule doesn't ever change. But let's talk about power of 10. Okay, so let me write down some decimal numbers. How about 2.25? Everybody's just looking so we understand. 2.6. And how about 2.783? Okay, we all agree that these have different numbers past the decimal point. This one has 3 numbers past the decimal point. This has 2 numbers past the decimal point. This has 1 number past the decimal point. Well, the first place past the decimal point is called the 10th place, right? So if I wanted to get rid of this decimal that only went to one place, I would multiply everything by 10. This one, I would multiply by 100. Here, I would multiply by tenths, hundredths, thousandths. So that tells me what number I need to multiply all the terms by just by looking at how many decimal places I need to go. Usually, it's the first 2. Those are the 2 we use the most. Okay? And again, all you have to do is look and decide how many terms. And again, once you find that out, you got to multiply all the terms by that number. Even if it doesn't have a decimal, you have to multiply it by that number. Okay? So I got a really easy question here, but I want to show you how it works. That's why. Okay? So I need everyone to write 0.5r plus 1.5 equals 3. And again, I know that this is an easy problem that you probably could do with decimals, but I wanted to pick an easy one to show you how this works. You can see that it's 1 decimal place. Is that correct? And as we just said, 1 decimal place is the 10th. So we're going to multiply everything times 10. So I'm going to put a 10 there, a 10 here. Remember I said even if it doesn't have a decimal, you got to multiply by 10 because of the equal sign. Equal says we're going to treat everything equally. So by doing it by 10, it's going to move that decimal place over 1 place. So this just becomes 5r. Plus, again, multiplying by 10 moves it over 1 decimal place. Now this becomes 15. Now 3, it's like 0.0, right? I got to move it over one place, and it becomes 30. So now that 0.5r plus 1.5 equals 3, now it's 5r plus 15 equals 30. And I can proceed and to solve it like a normal two-step equation. See if I can move these over a little bit to line them up. Okay, so I'm going to subtract 15 from both sides. Paying attention to what I'm doing. Subtract 15 from both sides. I'll cross that out, leaving me with 5r equals 30 minus 15 is 15. Then I'm going to divide both sides by 5. And I find that r equals 3. Okay? And again, I have to check it, right? So I have 0.5, and instead of r, I'm going to put the number 3 there, plus 1.5 equals 3. So we're going to check 3 times 0.5. Well, I can work on a side, right? So 3 times 0.5. I know 5 times 3 is 15, and because of that one decimal, it's going to be 1.5. So I'm going to change it to 1.5 plus 1.5 equals 3. And again, if you got to work on the side, find a place to work on the side, keep it out of the problem, add them all up, bring your decimal down. Well, you get 3.0, and isn't 3.0 equal to 3? Isn't that the same thing? Good. So that's why r equals 3 is our answer. So this skill that you're going to practice tonight, how to do, it's going to come in handy in the next couple of days, especially when we're talking about mixture problems.